I will have a pleasure to invite Professor Simona Iammarino, who is Professor of Applied Economics at the Gran Sasso Science Institute and a visiting professor at the London School of Economics and Political Science. Her main research interests lie in a period of multinational corporations, globalization processes, regional and local impacts of these processes, economic geography of innovation, technology, change, regional and local economic development and policy. So in 2024, Simona is distinguished scholar. She awarded the ERSA European Prize in Regional Science and also Giacomo Becattini Prize of Italian Society of Economics and Industrial Policy. So Simona is also a co-editor of Journal of Economic Geography and was a co-editor of Journal of Regional Studies I've already mentioned. So Simona, floor is yours, and we are waiting for your wonderful lecture.
Thank you so much. Thank you. Okay.
So yeah,
So this is it.
I'll switch the presentations.
Here that. Well, after that, I would like to have a photo with the Regional Studies Association so that I can post it to Sally Hage, that now is the CEO again, because I worked for the association for 10 years, so it would be nice to. Okay, first of all, can you hear me? I can switch. This is working.
Give you this microphone.
Because I tend to move, and normally people can hear me quite well independently from the microphone. But anyway, okay, first of all, thank you very, very much for this invitation. And we talked about it on a train in Italy with Agnieszka already a year and a half ago. And thank you to everybody. It's a real pleasure. It's my first time in Warsaw, which in a way is a shame, but I hope that this is the first of a long series of visits. And okay, and today I will present this line of research that I've been very, very, enthusiastic about. And I think it has a lot of implication for Europe and for European regions. However, for now, there are not studies really on this, particularly in the social sciences. So you will have to bear with me on the first, let's say, explanation of what I have been doing the last 8.5 years. When I started studying this stuff, it was because I read an article on The Guardian talking about the real importance of recycling electronic devices for the consequences of labor exploitation, human rights exploitation in the Democratic Republic of the Congo. I was really shocked by the article, so I went to my students say, hey guys, if you get rid of your phone, please recycle. And then I started thinking about how can I study this? How can I study this? And then finally I found a way to study, and you will see how. But my colleagues at the LSE, I spent 15 years in the Department of Geography and Environment of the LSE that I also directed for 4 years, will say, critical what is this stuff? What are you doing? So now instead is a big topic. Sometimes one has good ideas. So why critical raw material? Very quickly, what they are, how I study technological change with critical raw materials, how important this is for renewable transition, particularly in nation states, and how important it is to have them and produce them. And the newer part is that we studied in particular the current EU policies and strategies with specific policy target. We have a first very qualitative assessment of policy and express some of our worries about this that involves territories, that involves regions, first of all in the EU, but also outside the EU. So critical raw materials, they are they have been labeled the spices, the vitamins, or the current industrial transitions. They are used in really tiny, tiny quantities, but they provide mechanical, chemical, electrical properties that allow technological functionalities as anything else. Okay. So these are particularly intensive in the green and digital transitions. So our step forwards in this huge transition, technological paradigm shift, is related to these materials. Okay. On the other hand, however, the supply chain of these materials is particularly subject to risks, okay? Because of geographical concentration in places where there is political institutional instability, conflict, wars, because of trade wars, because of the current geopolitical situation, because of rarity of some of these resources on the planet as a whole. So for many different reasons. So the relevance, I don't need to say, because in the last 3 years, 4 years, people have stopped asking me critical what, because it appears a lot on the press, on different kinds of, institutional setting at the international global level. The African integration is also thinking a lot and pointing a lot to that. The G20, the G7, the European Commission, the US government, and so on and so forth. We have also seen increasingly wars on critical raw materials, tariffs wars, particularly but not exclusively US versus China, China versus US, restriction to exports from China to the US, big tariffs imposed by particularly Trump administration. So, I mean, it's been really very prominent as a public discourse debate. Now, which are these material? You can see here is a list of some with some technical applications. So you can see that we are always talking about batteries, lithium-ion batteries, and lithium and cobalt, very important for batteries. But in reality, these materials are very, very important for a vast range of technologies and vast range of products, industries. Okay. So from precisely, a magnet to medical implant to fiber optics to automatic catalytic, I mean, a lot of applications. So how we study critical raw materials? I started with PhD students. I still work with ex-PhD students that in the meanwhile have become professors, some of them. But this work, I'll present the list of references, is mainly carried out with George Lee, who is an ICHC student from China that with me at the LSE, and he went back to China. He's assistant professor at Shanghai Tech, and Andreas Cani, who got a PhD with me at the LSE for a decade at least ago, maybe more, and now he's an associate professor at the GSSI and other co-authors, you will see. However, I focus on technological innovation because I had to say, I was thinking about this, and I was lucky enough to meet an expert of mining about 10 years ago. at the university in Toronto University, the Monk School, and I was having lunch with him, and I was saying, I read about these materials. I read about the importance of that. How do you think I can study? Because they are, embedded in technology. And he said, Simona, you are an expert on patents. Why don't you look at patents? Bingo. So I had some seed funds from LSC, and one of my PhD students at that time said, okay, let's, text mine patents. And we saw it. And so we started to validate, and I'll show you some of, so which technology relies on which materials? These are example of the research question that we have progressively, answered. How critical raw materials supply influence the competitiveness of both in exports and technologies of countries, and what are now the current strategies and challenges that the EU faces? Is there a solid strategy, and which places win and which places lose in the current struggle and for critical raw materials for the technological transition? So, which technology rely on which critical raw materials? Okay. So technology, I use patents. I've been using patent data, USPTO, PatStat, and in the last 3 years, I've been working on the China National Intellectual Property Administration data with my Chinese co-author, obviously. And we focus on different sets of these materials because they are a lot, you will see, and different periods depending on the object on the specific paper. And moreover, we integrated this with a lot of other data sets on resources, for example, global mineral deposit production. There is the British Geological Society, a survey, United States Geological Survey, European Geological Data Infrastructure, and finally we bought S&P Global to have, it's not easy actually to trace these resources. Export, UN Comtrade, BACI, firm level patent data we merged between Orbis IP through the identifier of the firm with Orbis cross border investment. So it's a lot of work. It's been 8.5 years with basically no money, so just out of passion. And we publish a few things. So this is just an idea to give you, the extent of dependence on critical raw materials. These are the very big aggregates of technology in the technological classification. Okay, so you can see patents are human necessity, perform melioration, chemistry, textile. These are the big overarching categories, and you can see that they link to all his materials, okay, to a different extent, okay? And this is work that I'm doing with my Chinese co-authors. And you can see also that different technologies depend on different materials and to a different extent. So there is a lot of heterogeneity. Long-term this technological independence. We look at patent data initially between 1975 and 2015. Now, consider that these were more than 5 million patents. And we read and, looked into the text with text mining techniques, natural language processing in more than 5 million. So it took really a long time. At least 11%, roughly 11% mention at least one rare metals. Here, obviously, we had to select, the subset of materials because they are more than 70 and it's impossible to look for all of them. And you can see, right, that the number of patents that side of this one is growing, particularly in the latest years since the beginning of the 2000s. And you can see that the most, used in new technological environments, lithium, indium, cobalt, gallium, molybdenum, and relative to 1975, actually those that have grown the most are not cobalt and lithium, but in relative terms, indium, gallium, germanium, tantalum, and marianum. So we always hear about lithium or cobalt, but in reality, there are many that are even more important. Okay? How do we study this quickly? We apply the Schumpeterian tradition in innovation studies, okay? Relying on the material-based technological regime, because these materials are really a perfect fit for this theoretical framework, okay? Because the industries, right, that are based on these materials presents some characteristics, such as the knowledge base, for example, that is one of the main things in technological regime that tells us basically that the change in scientific principle brings about new materials that are integrated in technological discoveries, right? Technological opportunities emerge right from the new use of old materials or discovery of new materials. And obviously, the availability of materials also shape the appropriability, the rents that firms extract from this. And we are also at the stage of shift of technological paradigm, because the green and digital put together really shift enormously our, technological landscape, crossing industries horizontally. Example, just to translate into more common language, okay? So the appearance of new materials or the use of, old materials in a new way because you find new properties has always been there. If you look at the fathers of innovation theory, from Nelson, Winter, Dosey, they speak about it, okay? And you can see lithium and cobalt we know for battery, but gallium and germanium integrated circuits, tantalum in capacitor, molybdenum in transistor, and so on and so forth. Just to make you understand this connection with science and advancement of science, the evolution of solar panels, solar photovoltaics, is rooted in Einstein work on semiconductor materials. Okay? So the link of new technologies and products with scientific principle that have been evolving over time. Okay? So this is just and I'll show you just an example of this. So this is based on patents, okay, from the 80s to 2020, and we grouped renewable energy classifying the technologies as renewable energies versus all other technologies. And you can see how the renewable energy patents are classified much more often as renewable energy technology and material technologies. Okay? So patent classification for each technology have different classification, and you can see how much the patents in renewable energy actually rely on materials with respect to all the others. And on this other chart, you can see the share of patents that mention at least one material for renewable energy is substantially larger than for all other technologies. So, in other words, we cannot do the green transition without these materials, okay? So how these materials change competitiveness influence technological advantages and export product competitiveness. Here we focus on the renewable energy technologies, okay? So one important distinction that it becomes also clear later is extraction versus production, okay? So this is a very good example that I found in this amazing book, Material World by Ed Conway, that I recommend for anyone that is remotely interested in materials generically. And it shows how Swansea, a port city in Wales, became the capital of copper in the world from the beginning of the 19th to the end, the century until the end, beginning of the 20th century, to the point it was called Copperopolis, although it didn't have a single gram of copper under the soil. Okay, this is a very important key thing to keep in mind. There was an aggregate agglomeration of natural, comparative advantage, coal and water. This attracted scientists. There was the invention of the reverberatory furnace for processing copper. There was some entrepreneurs that was particularly, inventive, and Swansea became the world's leading copper producer. In the whole for 100 years, not having a pale idea of copper. This said you a lot because nowadays China is the world processor in chief for most of this material. Not all of them are actually owned by China. Okay, this is just to give you an idea. This is differences between production, so production of materials that are processed and are inputted in high-tech products, green products, sense, versus reserve, what you had under your feet. You can see how big the difference positive is from China. What does it tell us? That China secured the control of these materials also outside China. Countries that have natural resources, for example, you can see Poland, among others, Australia, US, Canada, are in deficit. Why? Because even not having the material, there are no capabilities to produce them, process, refine, and so on and so forth. So what we found, in fact, is that domestic production, independently from where the ore is extracted, supports a lot competitiveness of export and technological advantages. So now this is the geography of production. You can see who is the world processor in chief, okay? And you can see also this is for renewable energy related. There are some advantages here and there. You can see also Poland that is dark, so strong in Europe. And here, this is a comparison across materials also with those that produce the technologies. And you can see that the technologies are in the usual places, okay? Why? You can see Africa and you say, oh, a lot of deposits, right? Green dots, but almost black. Why? Because although they have the resources, these are extracted and shipped away for processing in other countries. Okay? So let's get to closer and closer to regions. What are the EU strategies? Okay, we know that there is a EU open strategic autonomy and a critical raw material act that is under the umbrella. The Critical Raw Material Act has come into force in March 2024. The aim of this open strategic autonomy, for definitions, we can have a very long discussion because there are hundreds and it's not clear. But in any case, it aims to establish a system of economic governance with bilateral relationship with are mutually effective and also fair and inclusive. Okay, there is the concept of ecological sovereignty that again has been, defined in various ways. I will provide later. In order to try to have a sort of control of the domain of technology and innovation, the priority areas of the open strategic autonomy are military and defense, energy transition, manufacturing of microchips. These categories are very weird, moreover, because some are very general, some are industrial, some are related to products, and the risking critical raw material supply that go into all the three above. Okay, so there are a lot of new documents on economic security, on industrial strategy, on Paris agreements that are really central for critical raw materials. Critical raw materials is everywhere. Ecological sovereignty. There are a lot of definitions. All these definitions are, refer to different forms of independence, control, autonomy of the Union towards the rest of the world. But it is from Jacob Adler is, the ability of a state to provide technology that are critical for itself. These are the list that the European Union, the European Commission of Critical Raw Materials since 2011. So this is not a new issue. Okay, we knew that it was becoming big. What you can see is that the number of materials has exponentially grown over time, and that in the last list in 2023, which is the current one, okay, you can see that the number of materials went from 40 to 34 with individual elements, because some are grouped. Rare earths are grouped into subcategories. Okay, so there are many more in terms of individual, or PGM, platinum group metals. Okay, so you can see that many more has been included. What is striking is that in the latest list, for the first time, not only critical raw materials are included, but also strategic, which are not critical, are not rare, are more or less widespread on the planet, but without which we practically are not able even to have electricity. These are copper, nickel, aluminium is in. So, we constantly add to our list. The targets of the European Union, which are similar the strategy of the US or the UK. The UK is perfectly aligned to the European one, are 4 targets, okay? At least 10% of the EU annual consumption has to come from extraction in the soil of the Union. Second target, at least 40% of our consumption has to be processed in the Union independently from where the material comes from. At least 15, now 25, last year has been increased, has to come from recycling. And no more than 65% of extraction or processing can't come from a single individual source or country. Because if that country, in the global scenario of today, is not a friend anymore, you are without supply. So these are the European Union, let me tell, that consumes, I think, around 1/3 of critical raw materials in the world, produces 3% at the moment. Okay? this is the situation. We revised all of the instruments that have been applied so far, and now I'm going solely towards the regions. And there are two main instruments in this Critical Raw Materials Act. The strategic projects that the Commission has set up in order to attract investment in mining and processing refining industry, so basically metallurgy industry, manufacturing, to pursue the 4 A's that I showed you, okay? The total, financial availability was around 30 billion euros. And here we, just classified both EU-based strategic projects and extra-EU-based projects, that there were deadlines. These deadlines to submit project proposals were very short. There are differences between those projects that are based in the EU towards projects that are based outside the EU, in the sense that the EU wants an accelerated procedure, but that applies only to EU-based projects. The project for substitution, the fourth aim target, is the only one that is really dedicated to R&D, but very low number of projects. You can see, within the Union, 2 projects and no projects outside. So the R&D to try to, lower the dependence is basically not funded. General lack of dedicated funds. If you look at an instrument that is equivalent, like the US CHIPS Act for semiconductor in the US, it provides specific new funds for R&D. We don't have anything like that. In the extra EU project, we don't find any EU-owned multinational. So the EU supports this project that are carried out by extra EU multinationals, but there is a procedure to evaluate according to EU standards, but then you cannot really, make sure, implement, there are no rules and so on. The other instrument, apart from this strategic project that moreover do not have autonomous funding sources, so it's a bit of a mix that comes from various existing sources, international partnership. And that is where, I think we failed completely. There are memorandum of understanding without any kind of enforcement or binding rules. Mostly are bilateral, okay? Bilateral means 27 countries, us, towards Ghana or towards Namibia, which is killing again multilateralism and obviously killing, really solid and mutually beneficial relationship. The EU has said that wants to collaborate with like-minded countries, which at this stage of human history is very difficult to understand what it means. And so, there are this sort of hubs, but, and so not real strategy, okay? Not real international partner strategy to develop something that can really safeguard our role. So we went through all this material. I have a PhD student, Diego Desi, that is spent 3 years looking at all the regulations and single documents of the Commission. And we came out with this, that in target 1, we saw only 6 of the strategic materials that go over the threshold of the 10%. In target 2, only 7 materials, and are always more or less the same. Only 3 strategic materials are actually given that, critical mass for recycling. And import dependence from a single supplier is, yes, maybe more feasible, but Ale is for processing, not for extraction. Okay? So overall, we can say that, this approach based on reducing the dependency of the union in is to increase our extraction and processing without thinking of two things. Why do we have them? It's not clear. Two, do we have the capability to process? Let's remember that mines in Europe have been closed mostly in the 80s. You are all too young, not everybody, but people like me can remember what happened in the UK and the coal miners and the Thatcher. It was a sort of end of an era, right? Moreover, both mining and metallurgy transformation are the most environmental unfriendly activities. So, did we get some kind of preparation for this in order to increase this domestic supply? We had a quick look at that, okay? And we saw that there is material scarcity, that opening a mine today, starting today, will bring to an operated mine in 10 years at least, okay? And requires massive investments. Geography, where are these things? And did we consult the people that are sitting on them? Okay? What are the environmental social costs associated with this? Had we considered social license to operate? And what about external, kind of relationship? So here is just to show you, right? EU compared to other areas of the world in some of, platinum, cobalt, lithium, and rare earths. And you can see clearly that the EU is not really very well endowed overall, okay? With respect to the rest of the world, you can see how Africa is big in some of them. Latin America is very big in lithium, okay? So, first day, overall material scarcity. Material scarcity here we got calculated since one of the problems in studying these materials is that the unit of analysis are very different. So you cannot compare cobalt with molybdenum, okay? They are incommensurable. So we just got the production calculated at zeta score. So this is just a standard deviation from the world average. And you have that the red means we had it more than the rest of the average of the world. The blue is we had less or an NP not present. There is. And you can see Europe is a row basically of bluish blue things. Okay? So, material scarcity. Mining capability in Europe. Well, as I would say, moreover, consider also that in Europe we are very good in environmental protection and regulation relative to the rest of the world. So there is a clash here. It's a sort of trade-off. We want to go ahead with the green transition. We want to increase domestic resources, but and I already said that. So potential gap, also capabilities, and this is just to show you now we are working on mining capabilities in region. What happened to the mining patterns over time? You can see that precisely in 2000, mid-2000, the rest of the world pick up. Look at where Europe is. And this is mining in general. And it's important now we're focusing on green mining because to be socially accepted, you have to do it. Okay. These are just impressionistic things. Where are these critical raw material? Who are the winners and the losers? Okay. Okay. First of all, and this is indicative, there is no centralized complete data sets of reserves and resources and deposits. These are three different concepts, but anyway, resources are amount of minerals that are identified with reasonable certainty, and also an economic value has been attached to them, right? There is nothing at the European level. There are national geological survey. There is a European data set, the European Geological Data Infrastructure HD, where we found that there are countries that are not covered. There are countries that provided the data 10 years ago. There are countries that provide the data today, and many of the minerals are not there. So, first of all, we do a policy without having evidence base, a sort of, and so eventually we this European HD is good to have a rough idea, but is very lacking in, and moreover, it doesn't give you minds. So you have a rough idea of what is there, but you don't know. So this is what we could map with SLP Global, that gives as a proprietary database that costs around 14,000 euros. Okay, we bought it, and for that we can see, mining projects at the stage of the art and resources, and you can see what the situation is. Okay, you can see that the mining projects are clustered in Europe, particularly in the west of the Iberic Peninsula, in the Scandinavian countries, and in Central Europe and Poland in particular. Okay? So, project status, there are many under development. It can take years, it can take depends. And some are close. Size class, because this is a matter of obviously multinational, but also in various stages of the value chain, as less big firms can be involved. This is the size class, in any case, of the mining properties, okay? And you can see that the picture. However, these are all the materials. I'll show you what happens when we go and we have hundreds of maps of this set. So this is bismuth, magnesium, manganese, and titanium. These are some of those materials for which we have to go over 10%. Okay? So one large down up there, you see what I mean. These are crucial materials. Platinum group metals, even less. Rare earths. Now, so this is the picture material for material integrating four different data sets, to understand what is going on, what we have, okay? This is Poland, which is a cluster for these materials in Europe. You can see that also in this case is not equally distributed territorially. And my argument is simply, we're talking about, physical inputs to knowledge and technology here. There is nothing more situated than natural resources. So to have a look at this phenomena without looking at where It's nonsense. There is not a single word in the Critical Raw Material Act, and for that matter also on the OSA, on regions. Okay? And I mean, since we are the Regional Studies Association context, and then I'm almost finished, I mean, we all know that the cohesion policy is dead, right? I mean, I am now starting a high-level expert group on territorial futures forum in order to see what would be the asset of territories. Regions has been cut as a word anyway, like the budget. Okay? And these are matter of facts, right? And we're talking about resources that are not volatile, that are under our soil. If you don't know where they are, you have a problem. And here there are the cluster mining in Poland. This is why I was particularly pleased to come here today, because you know obviously much more than me about this Lernica Global Copper District. By the way, critical raw materials, but my mining guru, Peter Warren in Toronto, already 2-3 years ago told me, Simona, be careful. Rare earths. Now there is all this mess. Rare earths are crucial, fundamental. Rare earths are very shallow in the sense it's very easy to extract them. They are in the surface, okay? While cobalt is a byproduct of copper and nickel, and you have sometimes to go where you cannot go because it's technically or economically unfeasible. What you have to look for is copper. Copper is everywhere. A copper without copper is not a matter of green or digital or not. It's a matter to have the light. And what we are consuming on the global level in terms of copper, it's not sustainable, not in the long, in the medium term. Okay? So that's why the Commission added to strategic. Okay? So anyway, you can see this. There is this KGHN Polska firm that maybe you can, I mean, I would be really pleased to have a good case study on this. Okay? I throw the idea at finding some funds to really make Poland, because, I mean, both on the firm side, on the government side, on the region, and also on the social civil society that is living in these areas, and just to know what they think about it. Okay? So, social license to operate. These are the consequences of multinational extractions in other parts of the world. Extraction of materials bring about destruction of the soil pollution, water pollution, destruction of biodiversity. So, green transition. Okay? I mean, we need the materials to develop the new green technologies, but we need to extract them, causing environmental damages. So, somebody has to think about, we had to think about what is, a solution here. And obviously also in Europe, more and more, okay? These are some of the big examples, right? Cova de Barrosos in Portugal, Trident in France, but I have many examples. Mellas, Berg in Sweden, a lot of regions. What happened in Belgrade with Rio Tinto was a huge story all over the place. So reaction of the people, right? Because you don't want, it's a classic situation where you don't want the mine in your backyard. Or even worse, you don't want the metallurgic plant. Okay? So, conclusion, too much emphasis on technological sovereignty without strengthening these interregional innovation networks that me, Agnieszka Romboszma worked on, right? I mean, to see how to develop linkages both within Europe and particularly between regions of Europe and regions that have outside Europe, okay? I mean, always the European Commission has always been front runner in cross-border cooperation, while we are retreating, as I said in other contexts. We are affected in what it seems to me to be a sort of Marshall Plan sort of syndrome that all the others we don't talk to, while we talk with the madman of the moment. Fragmentation, national approaches, which is what is happening, right? Is can break Europe even beyond. All this big transition depends on international networks and flows, okay? And regions that are not integrated in these networks are lost. Inconsistency between goals, targets, and what, as I said, there are no specific funds for this. There is no common data infrastructure to look at how it is evolving. Regional levels where the resources are not in the picture, and social license to operate is something that we never thought about. Moreover, we are not talking, I was in South Africa, and then I've closed for 2 months for a fellowship at Osalimosh Institute of Advanced Studies to really meet academics from there, okay? There were academics from Cameroon, from Ghana, from Zambia, Zimbabwe, South Africa. And they were telling me, Europe came. Ursula von der Leyen came to Angola, right? And they started talking what you want, what you need, Chinese come and listen. And then they do what they want, obviously. But it's not bilaterally 27 countries towards Zimbabwe that we can win the race. It's a totally wrong approach. This is my co-author. The papers that we have published, we have other stuff that is under revision. And thank you very much. Thank you very much for the attention.